Ready, right? Okay, so I want to welcome you to another statistical consulting class. Of course, on Monday we started scientific writing, scientific writing in statistical consulting, and of course I actually emphasize that scientific writing is statistical consulting is different from scientific writing for research or for papers, publish because the idea here is how you can communicate statistical idea in an effective way to the client. So here it's just you actually want to write you want to have writing, that will be able to answer the client problem. And of course, you need to be guided on, a well-structured, objective way of writing that, objective way of making sure you explain statistical analysis, results, assumptions, and so on like that, in a way the client will understand. And not only that, probably a recommendation, from from the research too. So I remember I said that if you want to begin the writing, just for you not to have you know um exaggeration on the introduction. You have to start writing from the middle. So start writing from the middle means you start writing from your results, because when you start from the results, you'll be able to know what method that work, or when you want to start writing the introduction. So, and I remember, if you want to start writing from your result, you need to fall first and back on the analysis of data. And I remember I told you the analysis of data is going to be done in two ways. The very first is to do what I call exploratory data analysis. Of course, in the exploratory data analysis is when you're trying to exploit your data, when you're trying to use some graphical means of depicting reality, trying to get maybe basic statistical summary and so on like that. And of course, after that, then we now go for inferential statistics. The story continues. Okay, so today we're going to continue from where we left off, because this is very crucial when you are writing, or when you're doing scientific writing. Particularly, you know, when you are trying to write reports when you're done with your analysis in your independent research. So how do we actually write in a way that not only statisticians we understand the message, we also want to use a kind of plain language that everyone will understand. I remember I told you the other time that you know you need to be able to know your audience, because your audience may not be statisticians. We have audience that come from you know everywhere, and you have to put them into consideration. So in order for me to further elaborate on writing from the middle, or dealing with the analysis, I think I'm going to continue. I'm going to use another example here. Okay, so we are curating a storyboard. We can only curate a beautiful storyboard when analysis has already been conducted. we already have the results, just like what I said the other time. I have a data set that we've even been able to work on. This is a data set on chicken weights. Okay, chicken weights data set. Okay, now I'm actually on this data set with intention in the data set is actually to see whether chicken when they have different treatments. When I say treatment, different feeds, whether they're going to have different weights or not. We really want to look at the effects of some selected feeds on the weight gaining ability of chickens. That is the intention in this research. And looking into this research, you know, we want to start writing from the middle. To start writing from the middle, it means our results are ready. We want to start from the results section. So I just wanted to say something. Okay, now I just wanted to see here. If I want to exploit my data, like I said, the data analysis, we start from the exploratory we're going to start from the exploratory level. Now, we don't just use pictures for using sake. There's a reason behind the use of every uh graphs. And I'm going to tell you this. Probably in the lower level statistics, you've come across analysis of categorical and quantitative data. I quickly want to have a recap on that. In the analysis, if I have categorical data, if I working with categorical variables, when I say categorical variable, I mean a variable with levels, more than one level. Now, if I want to describe categorical variable, I'm actually going to use a comparative chart. Why am I using comparative chart? Because the categorical variable has levels that I need to compare, between levels. And one of those charts is what we call, the bar graph that you're seeing right here. Look at that. That's a bar graph. Okay, another one we can actually use is the pie chart. But let me tell you this. Both pie chart and bar graph are doing the same job. I told you the other time, when materials are related, we can only keep one. Okay, and if necessary, you can decide to put the other one in the appendix. Now, between a pie chart and a bar chart, the pie chart and a bar chart, they are actually used to describe categorical variable with levels. So which means we're actually using them for comparison. Now, in order for us not to have tautology or duplicate of materials, we're actually going to choose one. I'm actually going to say this: majority. Okay, majority of the audience we go with the bar charts. Majority of the audience we go with this guy here. The pie chart is also nice, but don't forget, among the audience, some of them are not statisticians. I'm talking about clients right now. So they may not understand pie charts, but it's very easy to understand a bar chart in comparison. So if you actually start with this, you can put bar charts in the main report, and probably if you still want to retain the bar chart, you can actually put them in the appendix. Is there any question with that? Anybody good? Okay. Okay. No question, right? Okay. Now, if I now want to deal with the quantitative variables, and I want to make use of a graph, quantitative variables. Quantitative is different from qualitative. Qualitative is categorical, but quantitative, I'm actually referring to continuous type data. And what is my intention? Let me tell you this. Our intention, let me just quickly have this recap. Our intention using pie chart, bar graph is for comparison, and that's why they are used for categorical variables. But what's our intention using, trying to use histogram or trying to use box plots? We use histogram and box plots. We use them on continuous type data. And what do you think our intention is? Our intention is to be able to see the distribution of the data, okay, in case maybe one of the assumption using a particular inferential procedure is to first investigate the probability distribution of the data set. We want to see whether it is normal or skewed. Okay, so we can actually use a box plot for that. We can also use histogram for that. So if we also want to measure spread, we can also use it for that. So I'm actually going to say this. Okay, if you take a look at these the two of them are very, very important. Of course, the histogram actually, we really want to understand the probability distribution of the chicken weight. We want to see whether it followed normal distribution or not. That is one of the reasons using the histogram. And if you can see here, okay, it actually go from 100 to 450. So this chicken have different weights. But when I'm looking into the distribution of this weight of the chicken, okay, the histogram here does not capture the type of feed because chickens were given different types of feeds, different types of treatments. But this is not, we're not about that here because what we are after as a whole, we are interested in the way, this is distributed. But if I now want to see, situation whereby on a particular selected feed, I want to look into the distribution. The histogram is only going to give me the distribution in general, okay? The distribution in general. But when you take a look at this guy right now, okay, you can see the caption here, okay? I said chicken weight by feed type. If I want to tell about the distribution of this type of feed, I'm actually talking about this, okay? And of course, you've done what we call they were able to construct each of these box plots using 5-number summary. Has anybody heard about that before? 5-number summary? Okay. In the 5-number summary, you're actually going to have the minimum, you're going to have the maximum, you're going to have the three quartiles. The lower quartile, the middle quartile, and the upper quartile. And of course, if you take a look at this, I already know because this guy here is not in the middle of the box that I know there's a skewness. Okay, I know there's a skewness here. Okay, I know there's another skewness here. I know here this is actually kind of symmetric because you can see the Q2 that we call the middle quartile actually divide the box into two equal parts. Now let me also tell you this. You're going to have opportunity here to compare the averages. Look at that. They are not on the same level. If you look at the median here, the median weights, these are the kind of things we're actually going to see descriptive statistics, when we're exploring our data, to be able to think about trying to investigate whether there's a statistical significant difference between the weight, between the weight, the weight from different feeds. The box plot here is not going to answer a question that has to do with statistical significant difference. But this is just going to tell, it's actually going to flash a red flag. The red flag here is that this feed, okay, they may not, the resulting weight of chicken from different feeds are not necessarily, they may not be the same. But that does not answer a question that has to do with statistical significance. It's just like when police pulls somebody over. Police will pull a driver over based on suspicion, okay? Or he can just do that randomly, and he's just going to conduct his investigation. It is not all drivers pulled over by the police that get ticketed at the end of the day. Of course, I've been pulled over before and asked question and I let me go without any ticket. And there are some that they may get ticket in the process. So what am I trying to say here is that even though we're seeing that there's a difference here, okay, this particular plot is not going to answer a question whether the difference is statistically significant. Okay, and also going to show us possibility of outlier. Let me tell you this. We don't just do what we do. There are reasons why we do what we do. Um, if I want to use analysis of variance, maybe to test statistically whether the weights from different ways here are the same, one of the assumptions in using the analysis of variance is that there shouldn't be outlying observation. When I say outlier, according to Benkamp in 1982, outlier is a data point that is not consistent with the rest. Okay, so if you actually ignore that, okay, so when we see this, we know there's possibility of outlier, but we also have a way to investigate whether this outlier could cause a damage. It is not all outliers that could cause a damage to a model. If it's not going to cause a damage, then we're going to continue using the parametric model that we have in mind. But if it's actually going to cause a damage, then it means we may not use a conventional analysis of variance. We may decide to use a modified version of the analysis of variance, or we can even decide not to seek redress within a parametric means. We could go non-parametric. We have a non-parametric alternative to all of this situation where there's a violation of assumption. Okay, now away from that right now, away from that. So now I'm still exploring my data. Okay, now do you know the next thing I'm actually going to do? I've already seen from the image that there's possibility of differences between the weights, uh, weights that we actually derive from different feeds. So what we're going to do is we need to compute some statistical basis, like we want to know the average. But the very first thing we're trying to do here is, okay, how many chickens? I really want to know whether do we have a balanced design or unbalanced. Okay, because I got 6 levels of if you take a look at what I have here now, okay, we got 6 levels of the treatments. The casein, the os being, the NSAID, and so on like that. There are 6 levels of that. I really want to know how many chickens do we use for each? Okay, now we use 12 chickens for casting, 10 for husband, and so on like that. We're actually giving the audience impression that they were not equally replicated. Okay, this is unequal replication. That's okay. Okay, because we may not be able to have a balance. Okay, but that's okay. Now, can we find the average? If you take a look at if uh 12 chickens actually got casein, okay, and at the end of the day, we're gonna weigh them, each of them, each of the 12 chickens, with their weight, then we're gonna add them up and divide by 12. That is the mean here, 324. That very mean actually came from the 12. Now, and if you take a look at this, plus or minus the other side, okay, it's like it could represent the margin of error. Okay, it could represent the margin of error, and at times it could be standard deviation, where it's going to talk about moving from the center. Okay, if you're talking about casino now, okay, if the center here is going to be 324, and of course there's possibility it can go lower than that. It could be 324 minus 64.4 or 324 plus that. Okay, now if you take a look at what I have now, okay, you're actually going to see based on the average, based on the average, okay, based on the average now, if you take a look at this guy now, okay, the based on that very average, they are not the same, but we do not know whether they are not statistically, whether the difference is statistical significant. Something, there could be a difference, of course, naturally. Things are not the same. But before we can actually say, the difference is very much pronounced, if the difference is not negligible, we're going to say that difference has to be statistically significant. If I want to investigate that with all assumption hold, I'm actually going to use analysis of variance. Somebody's going to say, but I'm comparing means. Why not call it analysis of means? Why are we calling it analysis of variance? We're actually going to call it analysis of variance because we want to compare variation between with the variation within, because you know what happened? Okay, here among these 12 chickens that was given casein, when you measure their weight will not be exactly the same. There's going to be variation within. Okay, now there's also going to be variation between them. Okay, the analysis of variance actually split the sources of variation into two components. One, the variation within, and the other one, variation between. And of course, the ANOVA test that you're going to conduct will consider the ratio of the between variation to the within variation, which of course we're going to use F test. And if the F value is large, which means if there's a statistical significant difference between variation and within variation, there is possibility that you're going to reject the non-hypothesis. What is the non-hypothesis here? The non-hypothesis here is going to say the weight. There's no statistical significance difference in the weight. The weight from different feeds. Now, this is the result. Take a look at that. Okay. Why am I having 5 degrees of freedom? Because the numbers of level is 6. So it has to be 6 minus 1. Okay, so take a look at the p-value associated with the test. The p-value associated with the test is less than any reasonable level of significance. If you use a standard level of significance, this is less than that, and this is actually saying, okay, you need to reject the non-hypothesis. This is saying the difference that I noticed the other time, okay, the differences that I noticed in the box plot of comparison the other time, that difference is statistical significant. But let me tell you this, that difference does not actually imply practical significance. Please pay attention. There's a difference between statistical significance and practical significance. Okay, the p-value here will only answer a question that has to do with the significance of effects, but not effect importance. Not if I want to know how important or how large is the effect. I'm going to say that again. If I want to know how large is the effect, then I'm actually going to pursue confidence interval. I'm going to say this without mixing word. Anywhere in the world, you know, confidence interval is more superior to hypothesis testing. You know why? Because confidence interval incorporate uncertainty. Because confidence interval actually assume that when I repeat the process, 100 times, okay, 95% of the time, the population parameter, the true value would lie in the interval. Without you putting into consideration, you've incorporated uncertainty. Now that will answer a question that has to do with the importance or the practical significance. Okay, so now because of that, if you take a look at what I have now, we've rejected the non-hypothesis, indicating there's a difference. Okay, now the question now is, before I go into the practical significance aspect, or before I go into uh, where the different lies, okay, it is very important to investigate model diagnostics, investigating assumptions. Part of what you're going to communicate to the client is to tell your clients whether assumptions underlying the use of the model are not violated. A model is only going to do a great job if assumptions are met. Otherwise, it's going to be an exercise in futility. Okay. Now, what are the assumptions underlying the use of analysis of variance in this regard? Okay. I'm actually going to talk about assumptions of normality. Okay. I'm going to talk about assumptions of normality, assumptions of linearity. Okay. I'm going to talk about assumptions of constant variance. Okay. I'm going to talk about assumption of absence of outliers. We have a way to investigate this. If I want to investigate normality, what normality am I talking about? The normality of residual. Of course, I can make use of a normal QQ plot. Because here it appears they are all on the diagonal straight line. Okay, that assumption is met. Assumptions of normality is met. If you actually want to answer a question that has to do with whether assumptions of constant variance met, you can use residual plots. This is the residual plot. You're going to look at the plot of residual against the fitted. The plot of residual against the fitted, you look at the variation here, the variation here. Oh my God. When you take a look at the variation across, they more or less look the same. So with that, I'm actually going to say assumptions of constant variance hold. Okay, here we're going to say, oh, the model is almost stochastic. The model is almost stochastic. Okay, now you can also investigate, the other time when we were exploring the data using the graphical plot, of a box plot, we actually saw outliers, right? We suspect outliers. I'm going to go back. Okay, can you see here? Okay, can you see those points? We suspect outliers, and we also need to investigate that to see whether the outlier would be damaging or not. And of course, we're going to use a Cook distance. Take a look at this. That's what we're using here. Okay, Cook distance. Okay. Before coming to the United States, I've heard about Cook distance, and you know what? Professor Cook is actually a colleague at the School of Statistics here. So to tell you that We got some, highly sophisticated intellectuals in the School of Statistics, University of Minnesota. Okay, so now away from that, like I said, investigating assumptions are necessary because a model is as good as assumptions put into a model. Now, the next thing that I want to investigate now, the other time we rejected the non-hypothesis, right? Because of the fact that the p-value was less than a given level of significance. The next thing we're going to do is to uh, you know, we actually need to investigate further to know where the difference lies. Oh, is it different between this treatment and this treatment, or that treatment and that treatment? And that is what we're gonna call that multiple comparison test. The multiple comparison test is actually needed when the non-hypothesis is rejected in the analysis of variance. We got different kind of them. We got turkey, we got Ben Ferroni, and so on like that. But you know what? Turkey test is popular. Okay. Now I just needed to pay attention now. With the multiple comparison test, you're actually gonna have opportunity to compare the levels of treatment on a pairwise level. Take a look at that. Okay. Can you see that? Okay. Now this is the difference between any pair. But we all know that difference exists. Okay, none of that is zero, because if it is zero, we say there's no difference at all. We all know that difference exists, but the only way to tell if the difference that exists between any levels of treatment is statistically significant is to either check the p-value associated with that, or you look into the confidence interval. Now let's take a look at this. If I actually want to focus, take a look at this guy. That is the difference. That very difference may not necessarily be effect size. Now take a look at this. May not really be huge. If I want to use a p-value, this is the p-value associated with that. Now that very p-value now is trying to say the difference between ox bean and casein is statistically significant. If I don't want to use a p-value, if I actually want to use a confidence interval, please pay attention. If I want to use a confidence interval, the only condition under which you're going to fail to reject the non-hypothesis is when zero is in the interval. Okay, take a look at that. Do we have zero in this interval? No. This is actually going from negative to positive. When you have negative to positive, or you have positive to positive, that is a sign of statistical significance. But situation where you have from negative to positive, it means zero is included in the interval. Then it means even if different exists, it's not going to be significant. I'm actually going to, let me see which of these. Go, oh my God. Can you see that? Can you see that? Negative to positive, it means even though this particular difference actually occur between the meat meal and linseed, but that difference is not statistically significant, and the p-value also agree with that, because here the p-value is greater than the level of significance. You can see the p-value and the confidence level agree, confidence interval agree. So with this, you'll be able to point out where the difference lies. You will not be able to see where the difference lies when you conduct ANOVA. Okay, but you're actually going to see where the difference lies when you, after the ANOVA result, okay, then you go further to conduct a multiple comparison test. Okay, now it is time for story. You want to, because you have results now, you've done exploratory data analysis. You've also done inferential statistics. And the next you want to do now is you just need to start writing. Okay. And as I said, how did you group your findings? What messages are you trying to tell? What tables and plot did you want to include? We're not going to include all tables. Okay, I said it the other time. If two tables are giving the same statistical information, in order not to make our writing to be noisy, we can drop one or probably put that in the appendix. So how are we going to sequence them? How will contextualize and having a transition between them? I just wanted to pay attention now. Okay. I said it. Writing from the middle is writing from your result section. Okay. You can write anything about results when you have not conducted analysis. And that was what I just showed you right now. Okay. We talk about when you are writing, you need to be able to let the audience know whether assumptions are violated or not. Okay. That's what I'm trying to say here. We have to check whether assumption hold. Let me tell you this. Some people will say, I don't care about assumption provided my p-value is statistically significant. That's not true. Somebody can commit an offense in the state of Minnesota and run to state of Illinois and run to Chicago. And if a court in Chicago should get the person arrested, and they tried the person, and they were able to establish the fact that he committed an offense, and they now sent him to jail. Do you know the court in Chicago, the court in the state of Illinois, whatever decision they take will be declared null and void in law because they do not have a territorial jurisdiction. Because the guy did not break state of Illinois law. The guy broke Minnesota law. So what they need to do is to repatriate that guy back to the Minnesota to face justice. The same thing here. Okay, if assumptions are violated and you don't care about that, then it means you are operating outside the jurisdiction of that particular method. So even though you are able to get a statistical, significance, putting into the p-value, you're still going to mislead. Okay. Now I talk about foundation, what you need to explain in the results, and what you also need to eliminate. Okay. Then you actually going to do iteration, add, remove, rearrange until everything look presentable. Okay. I'm actually moving right now. In case if there's any question, please let me know. If you want to read more on how to communicate statistics effectively, I will advise that you read this article by Nolan and Stout 2021, Communicating with Data. How do we communicate? Okay. This was actually published by Oxford University Press. Okay, the art of writing for data science. If you want to learn more, okay, and you can access the electronic version of the book for free from the university library. So I will advise you if you really want to learn more. I told you we don't want situation whereby you put in an effort, starting from you having a good design. You've collected an appropriate data, you've reliable data, you've used an appropriate statistical methodology, you have very convincing results, but only to be let down by by the way you communicate that. Communication is a key. Okay, communication is a key, and that is the reason why this course is called, you know, um, consultation and communication for statisticians. The communication is very, very crucial. Okay, So on the chicken, so now I just put an example of how that can be communicated, with Ron. You have to let the audience know. You only focus on one response variable. The outcome variable here is just the weight of the chickens. And you actually conduct your analysis, the exploratory data analysis and the inferential analysis on that particular variable. Now, this is what I was saying the other time. Because of the fact that the pie charts and the bar plots are doing the same thing, we can eliminate one and only report one. You may not completely eliminate that. You can put that in the appendix in case. Okay? And but if you take a look at the histogram and the box plots, okay, I don't think you can eliminate any of that because the histogram here is actually focusing on the probability distribution of all the weight of all chickens. But the box plots provided us information if I really want to see the distribution of the weight of chickens within a particular treatment. So you can't eliminate any of that. You need to report it too. They are very, very crucial to your findings. Okay, now I think I have explained that. You can see here. Now I'm trying to write a story now. If I retain something, if I retain the material, whether it is graphic or it may be a tabular presentation, I think I need to tell a story. Okay, that is the scientific writing that I'm talking about. Take a look at this. I said, okay, each feed group has between 10 to 14 chickens. How do I know? Because 10 here, the maximum is 14 for the soya bean. You know, despite the fact that I have that on the table, I don't want to I don't want to leave the interpretation of the table at the expense of, at the mercy of the client, because the client may not have statistical training to be able to interpret a table. So I don't want to do that. And that's why I need to also tell a story. Now, I said the chicken weight differ by feed. Okay? The chicken weight differ by feed. How do I know that? I know that from here, and I also know that from here when you put into the consideration the average. Okay, I said divide by feed, and I said on average, the casing and sunflower group have the highest chicken weight. So I need to provide that information. This information that I'm providing now, okay, how do I actually get that? I get that from the comparing the mean across, or you can look at the box plots. Okay, and I said which is about 330G. I have to be specific. Okay, the Oxpin group has the lowest. As you can see now, look at that in the box plot. It's as the lowest, okay, as the lowest, okay. And the weight is at 160. If you take a look at, if you take a look at what we have here, I'll give me 1 second. If you take a look at that, okay, that may go to 160. Okay, so if you take a look at that, okay, so I'm doing scientific writing now, and I did not only talk about the mean. I also talk about the standard deviation as well. Okay, I said based on the standard deviation, the casein and the meat may grow vary most in the chicken weight, because at times we in addition to looking to the average, which is the Sarah, I also want to see how they vary. I want to see the way the data spread out. Okay, and this is trying to tell me, if you take a look at the casing, okay, 1 second. If you look at the casing, okay, here, okay, if you look at the standard deviation compared to others, okay, the casting and meet me, can you see that? I think they have the highest variability. You can talk about all of that as well. Okay. Now, now take a look at this. When you run the analysis in now for the analysis of variance, this is not the only thing you're gonna see. No, that's not the only thing. There's going to be a lot of outputs. Does that make sense? It is not all of them that you're going to put. It's not all of them. You can simply write this guy just like that. Just that one. You can the detailed, comprehensive how to output. You can put that in the appendix. For them to see that you've really run. If you want them to see your codes, okay. And look at the way I actually interpret that result. Okay. I did not say my test show. I had to give the name of the test. I said the F test shows, not me. It's not my method. It's an established method for testing for the equality of means when you have more than two categories, no more than two groups. I said the F test shows that there is significant difference among the meat chicken weight of the five feed type groups. No, that should not be five. There should be six. Okay? You have to correct this guy here. We did not consider five. I think it's just talking about this, the largest degree of freedom. Okay? If you come back, you have to report for all is for the six, not for five. Can you see that? 1, 2, 3, 4, 5, 6. Okay? So you have to correct that. That is not 5. I mean, correct this guy here instead of 5. Okay? You actually say 6 because there are 6 levels. And I indicated the p-value. You know, when a court take a decision, the court is not going to say the judge that actually read out the verdict is not going to say this is my verdict. No, it's not his verdict. No, no. Is the evidence, they use the evidence before the court. Does that make sense? So it's going to say this court, not me, because the court is going to operate within a constitution, you know, within a particular, you know, they have the sections in the constitution, that they actually have to follow. Okay. And that's why I love the jury system. Okay. In some places where there is no jury, of course, the judge can just decide. And that's why there's going to be an appeal. Anybody can appeal. So if you take a look at what I have right now, this is not just saying my method. This is actually just saying the appropriate approach that we found. Okay. We're actually hiding under that. Okay. So, that's all what I have, for you today. Let me see. Okay. So, these are just, assumptions that I talked about the other time. Then you also need to interpret, where you find the difference. Okay. So, and that's it. So that's what I have for you today. We're meeting again on Friday. And make sure you keep track of announcement section in case information is going to be going round. Make sure you all stay safe and have a lovely day. Bye for now, everyone.